Welcome back to our Physics 141 demonstration series. Today we are going to learn how to measure the speed of waves on a stretched string. And we are also going to relate the speed of such wave with the tension applied to the string. So here is our experimental setup, which consists of a string that has one of the endpoints attached to this mechanical vibrator, which is powered by some frequency generator. The other end of the string hangs from this pulley, and here we have some weight to make this string tense. Now, when we create a wave in a string that has the two endpoints fixed, the wave will reflect back and forth at the boundaries, creating a standing wave. Now, if the wavelength is a whole number fraction of the length of the string times 2, and here n is an integer, 1, 2, 3. So when this condition is satisfied, then the nodes of the waves will be at the end point. And so when the wave reflects at the end point, we'll lose the minimum amount of energy and will produce large amplitude waves. And here we have an example. So in our example, we are going to take n equal to 1. So let's see how this works. So I'm turning on the frequency generator. And as you can see here, we have the n equal to 1 mode. So now, what we can do is measure first the length of the string, which is 86 centimeters. So L is 86 centimeters. We know the frequency from the generator, that is 120 Hertz. And so with the value of L, because we know is the n equal 1 mode, we can determine the wavelength. Okay? So in our case then, once we determine the wavelength and once we determine the frequency, we can get the speed of propagation of the wave. That in our case, as I said, is L is 86 centimeters, frequency 120 Hertz, and this gives a speed of propagation of 206 meters per second. Now, the speed of propagation actually depends on properties of the system, and in particular, the tension of the string and the mass per unit length of the string. So the speed is also equal to the square root of the tension of the string divided the mass per unit length. In general, the mass per unit length is denoted by the Greek letter mu, and for our case, we have a mass per unit length of 2.4 times 10 to the minus 4 kilogram per meter. And we also know that the mass is the mass of the tension that we have here at the bottom is 1,050 grams. So if we multiply the mass by the acceleration of gravity near the Earth surface, which is 9.8 meters per second squared. And so we have to be careful here with the units. So the length of 86 centimeters is also equal to 0.86 meters, and 1,050 grams is 1.05 kilograms. So putting all this together, then we multiply m times c on the correct units. We get the tension, and we divide by the mass per unit length. We take the square root, and by doing that, we are also going to take we are also going to get a speed of propagation of 206 meters per second. So now you need to do the experiment, but you are not going to use a system like this, but instead we'll be using some simulation system. See? So here we have the interactive physics simulation system created by physics that mimics this experimental setup that we have here with a string, and the two endpoints are fixed. Here we have the pulley, here we have the weight, and the idea is that by using your mouse, you can adjust the vibration frequency, the linear density, and the tension. So here we see the vibration of the n=4 mode. We have 4 peaks there, n=4 mode, and that is produced with a vibration frequency of 125 Hertz. Because we know this length L, and we know that N is equal to 4, we can determine the value of the wavelengths. And so with the wavelengths and the frequency, we will be able to determine the speed of the string of that system. We can also check that by using the tension and the string and the mass per unit length V. So what you are supposed to do then is adjust different values of the tension, linear density, and vibration frequency to find different resonant modes and test that these two formulas give exactly the same result. So the link to this webpage is in the lab manual. So with that, you have all the information you need to do the lab. And this is all, folks.